Hi everyone, in this video we're going to make this line fill plot using Python and Matplotlib. I was inspired by this nice graphic in the New York Times where the authors compare the historical average reservoir levels of water in California to the levels this year, focusing on the recent rainfall. The point isn't just to copy this visual, but instead to learn what tools are available so that in the future we can make effective plots and visuals. Feel free to skip around to the parts you're interested in using the chapters below. All the code and data are available on GitHub using a link in the description.
First, let's import Matplotlib and Pandas. I know this is a Matplotlib tutorial, but you'll find that Pandas is really helpful for dealing with data in a tabular format, such as in a CSV. Next, we're going to read data from CSV. I'm going to use this function pandas.readCSV, and I have data in two different CSV files. One is for the historical data, and the second is for the data from this current year. Let's also take a look at the data to see what's inside. You can see we have two different columns. The first is the date, and the second is the level, and that level is the fractional capacity of the reservoir. The next step is to transfer some of that data into numpy arrays, and the syntax here is dataframe.level, or whatever column you want to use, .toNumpy, turning it into a numpy array that Matplotlib will be able to easily plot. We do the same thing for the other y values, but for the x values we have to treat them a little differently. We use this function called toDateTime to change them into a date format that Matplotlib will be able to more easily recognize. And again, we use the toNumpy function to change them into numpy arrays. Now that we have our data ready to go, we can start making our plot. To make our plot, we can check out the Matplotlib website, and here's a page that shows filling the area between lines, which is what we want to do. The basic usage is ax.fillBetween x values and y values, and that'll give you a fill between y and 0. If you wanted to, you could also do between two different curves, y1 and y2, but we're looking to do a fill between y and 0. We use this function plot.subplots, which generates a fig and an ax object that we can plot with. And then we run ax.fillBetween, with the syntax being the x historical values and then the y historical values. And let's see what this looks like. As you can see over here on the right, we do have a curve, and everything underneath the curve is filled in, which is exactly what we're looking for. Let's also plot the current year's data, and I'm going to also give this a black color, because if it was the default blue color, you wouldn't be able to see it. Oops. Okay, so we can see the historical data, that's all filled in, and we can also see the current year's data plotted as a line. Now what you might want to do is bring the current year's data to the front and then send the historical data to the background. And the way we can do that is by adjusting the alpha value for the color of the fill. And alpha corresponds to the opacity of the layer, so a high value of alpha will be something that's opaque like what it is now, and a low value will be more transparent. And now we're almost done. All we really need is a y label and we have a reasonable plot. In this case, the y label is the fractional capacity of the reservoir. And with that, we have a good enough plot for most applications, especially if you're just trying to share data with friends and colleagues. But in this case, since we are using this New York Times figure as our reference, we can take a few more steps to make our plot look more like that New York Times reference. One thing we can do is modify the figure size. There's a dictionary inside Matplotlib called rc-params. And if we control figure.figsize, we can adjust the figure size to whatever ratio we want. There are many other parameters inside of this dictionary rc-params, and one that I like to use is figure.dpi. That's dots per inch. And you can set this value to whatever value you want depending on what resolution you need for your figure. When we run the cell, you'll see that the figure size has changed, and we can adjust the proportions to get it to be just the right size we're looking for. What you'll notice here, though, is that some of the months on the x-axis are overlapping, so we'll need to figure out a way to limit the number of months that show up on the x-axis. To do this, we can check out the Matplotlib website again and look at this date tick labels page. The way to adjust the months is to import this mdates and set the x-axis major locator using the syntax here. Let's give that a try. So I'm going to import that right here so we know in the future how we got here. And I'm also going to select by month to 1 so we only see January show up. If you want to include multiple months, you would just change that 1 to a tuple. So if we set that to 1 and 7, now we get January and July. For now, I'll just change that back to January. Returning to our reference image, we'll need to figure out how to remove the y-axis and also how to remove the spines on the left, top, and right of this plot. But before we remove this axis, I just want to point out that this is usually not something you want to do. Usually you want to have some values on the y-axis to orient your viewer in terms of what do these values on your plot actually mean. I think what the authors of this plot were going for was drawing a contrast between this recent year's reservoir values and the historical average, and also bringing your attention to what happened in January 2023. So if you want to remove the y-axis from your plots, or the x-axis, I'll just suggest you proceed with caution. We can use this function setVisible false, and we can do this with the y-axis first, so y-axis.setVisible and false. And we can also do this with ax.spines and then choose which spines we want to set invisible by calling them with a list. So all of the options inside of the list will be set invisible. And we also have control of the format of the date. Maybe you don't want this to say 2022-01, you want it to be a little different. I copied in some notes here. Here's how you can format. You can use this % followed by M, D, capital Y, lowercase y, or B to format the date. We're going to import date formatter and set this date form variable based on the format that we're looking for. And so in this case, we're going to do %b, which means it'll be JAN dot new line and the year in 4 digits. And so that's how we'll format this. And we need to set the major formatter on the x-axis to this date form variable. Oh, let me fix that. And now we have this jan.2022, just like what we wanted. Now the last thing we need to do is to add some text to label these 2 different curves, so it's easy for the audience to see immediately what's going on. Now there is a way to do this using matplotlib, but I think it's fairly complicated and tedious to get it to look nice using matplotlib. I would recommend using a software like PowerPoint or some other vector editing software like Inkscape or Adobe Illustrator to add some text directly to the plot, so then you can really tweak it and adjust the font size, adjust the font to just what you're looking for more easily. But in case you really want to know how to do this in matplotlib, here's how. We use this function ax.text, and ax.text takes in 3 different variables that you need. You need an x value, a y value, and your string. And that x and y values correspond to the coordinates on your plot where you want your string to be printed. So I found using these values gets us pretty close, and maybe we want to change that y value from 0.45 to 0.42, and this looks pretty good. But you can see why if you really wanted to get it to the exact right point you're looking for, this could take a lot of time and a lot of tinkering in choosing those values. Personally, I think it's much easier to use something where you can click and drag your text right to the exact place you'd like it. So I'm going to comment that text function out and then run plot.savefig to save our figure so we can open it up into a new software and add that text later. But after that, we're finished. And after adding that text, here's what the plot looks like. I hope you all enjoyed the video. See you next time.